Hey there, class. We're here today. What we're going to do is look at how to add two vectors together, and we're going to do this through mathematical means. Now, in previous videos, we've looked at how to do these graphically. We've also looked at how to do these in kind of a conceptual way. But this is where the rubber starts to really hit the road, where we can take two vectors and we can actually add them together and get an actual mathematically correct answer. So that's our goal here today. So let me scroll down and let's look at the example that we're going to see here. So we're going to take two vectors. The vector A is a 14-meter eastward direction vector, and the second vector is going to be the vector B, which is 5.5 meters to the south. Now the goal here, again, is to add these two together. And when we add two vectors together, the idea or the result of this is actually something called the resultant, which we have looked at in previous videos. So I've actually drawn these to scale already. This is not really a requirement for when you're doing this mathematically. I really strongly recommend that you draw something close to scale, so that way at least you have an idea of if your answer that you get mathematically makes sense. So the resultant is always drawn from where we start to where we end. And again, this is something called the tip to tail method. There is actually another method called the parallelogram method, which we can show you in another video as well. So if we draw the resultant is drawn like this. So certainly, one thing I hope you note here is that this does make a right triangle. That is an important thing. Of course, right triangles allow us to use certain things, certain equations that we know only work with right triangles. Also, I want you to make a note that the angle that this resultant is at is measured or could be measured from the easterly direction kind of downwards in this way. And again, in a previous video, we talked a little bit about how to make these measurements, these angle measurements. So let's actually get started with the math that's involved here. So we have this here, it's 14 meters in length, and we have this right here is 5.5 meters in length. Now, of course, I hinted at this earlier, but basically this is a right triangle. And in a right triangle, we should know that there is a certain theorem that works, and that is something called the Pythagorean theorem. And we'll see how good of a speller I am there. I think that actually might be right. I don't know. It doesn't spell check it for me here. But the Pythagorean theorem, I'm not sure I can spell theorem. That doesn't look right. But at any rate, the Pythagorean theorem basically says a squared plus b squared equals c squared. And in this case, specifically for us, we're going to be taking the magnitude of the vector A plus the magnitude of the vector B, and we're squaring both of those, and that's going to have to equal the magnitude of the resultant vector. And so we can get the magnitude of the resultant vector by using the Pythagorean theorem. Let's put our numbers in. This is going to be 14. We're going to square it, plus the magnitude of B, which is 5.5. And that's squared, and that's going to equal this guy here squared. To get the r by itself, we will have to square root both sides. And I'm going to get a calculator out and see what I get. Okay, so here we are. Let's put this in our calculator. We're going to take 14 squared plus 5.5 squared, and that's going to equal 226. 0.25, and then we're going to square root that, and we get what? 15.04 and a whole bunch of other numbers there. And in our original, I guess, problem here, both of these have two significant digits. So I'm not all that worried about significant digits, but we'll stick to, I guess, the convention, and we'll just write down 15 for our answer there. So going back here to my screen, we're going to have r. And this is the magnitude of r, notice, is 15, what are we dealing with? Meters here, I guess, right? So going up here, I know that the magnitude portion of my vector, the magnitude here, is going to be 15. Now, if you've watched any of my previous videos, you know that this isn't the end. You know that a vector has two things that we have to be concerned about, magnitude being one of them. And the second thing, of course, is a direction. And again, we hinted at that earlier, where we were dealing with this angle right in here. This angle right in there had to be found to know what to fully define our vector. So that being said, of course, in a previous video, I did a measurement of this, but today we're going to actually look at how to actually calculate this, because that's the goal, is to do this all mathematically. So one important thing to mention is that this is a right triangle, and with right triangles, we do have some tools in our toolbox. One of those tools is the Pythagorean theorem, and a second thing would be something that you may have known from your trig class or maybe a geometry class, and that is this. SOHCAHTOA. These are, of course, the trigonometric functions, where sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So certainly these are possible ways we can find an angle as well. So I'm going to just rough out the picture here. We had a vector here, we had a vector here, and we had a vector here. This was the 14 meters, this was 5.5 meters, and this is a 15 meter vector here. Now, I will tell you this, I'm going to always aim to use non-calculated numbers if possible. Notice that this number right here is a calculated number. So I'm going to avoid using that if I can, just because we often round off calculations. So I'm going to stick to using my 14 and my 5.5. Our goal here is to find this angle right in here, and we're going to call that theta. Notice that if we go here over, this is what's called the opposite side of our triangle, and this one right here, notice the angle, or sorry, the 90 degrees is here, so this is going to be the hypotenuse, and then this would have to be the adjacent side. So again, considering I don't want to use this one, and I want to use the 14 and the 5.5, there's only one trig function that actually works out here, and that's going to be using the opposite and adjacent, and that's going to be the tangent function. So let's write this out. Tangent of my theta equals the opposite side over the adjacent side. Now, substituting in specifically what I'm dealing with, that's going to be tangent of theta equals, I guess the opposite side here is what, 5.5. And our adjacent side is the 14 meters. Okay, and one thing to note, I am trying to solve for the theta that's right here. To get theta by itself, I actually have the inverse tangent on this side, and likewise I'm going to have to do the same thing. Let me just copy and move this out of the way. I'm going to have to do the same thing on this side as well. So I'm doing the inverse tangent function of this thing right here. I'm going to get my calculator out and see what I get. Okay, so here I am with my calculator. One thing to note about when you put this in your calculator, you're going to want to make sure that you, at least in my class, for the most part, you're going to be in the degrees mode. So you want to make sure you've put your calculator in the degrees mode. And then, because of course, when you're dealing with trig functions, you need to either know if you're in radians or degrees. We want to be in degrees. So let's type this out. In this calculator, I have to do 5.5 divided by 14. I'm going to get that answer. I'm going to hit the equal sign. And then I'm going to do the second, and I'm going to inverse the tangent of that. And I'm going to get 21.4 and a whole bunch of other numbers here. I guess, again, since we're dealing with, it looks like two significant figures, we'll answer in two significant figures as well. So that's going to be 21. So going back over here, my theta will equal 21 degrees. Okay, so we've just found out that the angle that we calculated right here was this 21 degrees. Now, if you've watched some previous videos, you'll also know that this 21 degrees has to have something else involved here. Again, this 21 degrees could be anywhere along here. It could be a 21 degree angle in here. It could be a 21 degree angle over here. So the idea here is it is a certain 21 degree angle. In this case, it's going to the south of east. So it's going to be 21 degrees south of east. All right. And so when we mathematically add the vector A and we mathematically add that to the vector B, the resultant we get is a vector of 15 meters, that's its magnitude, and its direction of 21 degrees south of east.